Sup Sigma fan, welcome to episode 2, getting into some kind of trickier kind of SUVAT scenarios in this particular episode. So yeah, we're going to work our way through 5 more questions, all involving SUVAT equations. A couple of trickier ones involving quadratics, and then a couple of ones right at the end which do involve using a particular quantity, that being acceleration due to gravity. Alright, so yeah, without any further ado, let's sum up those SUVATs. Alright, so don't forget that you guys can click down below. You can find in the description there will be a link to this PDF, this worksheet, if you want to print it out and have a go before I go through them. Or if you just want to print it out and kind of work along with me, it's entirely up to you. But yeah, let's get it started. So you got a motorcycle accelerates from rest at 12.5 ms to the minus 2 for 4.5 seconds, and then halves its acceleration for an additional 3 seconds. Travels at a constant speed of 2 seconds before undergoing a constant negative acceleration to become stationary after traveling a total distance of 650 meters. So, I mean, pretty wordy question, right? Pretty wordy question. Most importantly, we can kind of see that there are 3 different types of motion inside this question. So there's the acceleration from rest at 12.5 ms to the minus 2 for 4.5 seconds. And then a second period of acceleration where its acceleration is half of the 12.5 for another 3 seconds. And then it's a constant speed for 2 seconds. And then there's the negative acceleration. So sorry, 4 different types of motion, I should have said. As a whole, so overall, it covers 650 meters. So find the highest speed reached by the motorcycle. So this would be the end of the second section. First section, it's accelerating. Second section, it's still accelerating. Third section is constant speed. So it's the end of the second section that we're looking for to find the maximum speed reached by the motorcycle. Okay, so initially starts from rest. So we say that our final speed is going to be our initial plus, now this is just our acceleration times time for the first section, which is going to be our change in velocity in that first section. And we need to do the same thing for the second section. So our change in velocity for the second section is just going to be the acceleration, which is 12.5 over 2, or 6.25 for those 3 seconds. And pretty much we just add all 3 of these together, and it's going to give us our final speed of around about 75 meters per second. So highest speed reached by our motorcycle is about 75 meters per second, and that's going to be at the end of the second leg of its journey, okay, the second part where it's accelerating. What about the distance traveled before undergoing negative acceleration? So this is the first 3 legs of its traveling, the high acceleration, low acceleration, and then constant speed. So we need to find the displacement or the distance covered in each of those 3 legs and basically sum them up. All right, so our first one is acceleration leg, so it's just going to be ut plus half at squared. It does start from rest, so we know that our u1 therefore is going to be 0, and our acceleration is going to be 12.5, and it does it for 4.5 seconds. So 0 plus half times 12.5 times 4.5 squared. This will be our displacement for the first section. Okay, and again, this is the section where it's undergoing that large acceleration, 126.5 meters, thereabouts. Do the same thing for the second section. Now ut plus half at squared again, but recognizing that u is not 0, okay, the u for the second part of the section is the final speed for the first part of the u for the second part of the journey is the final speed for the first part of the journey. Okay, so that's 12.5 times 4.5. Okay, and then we're going to multiply that by our time of 3. So this 3 comes from, it's 3 seconds for the second section, so t is equal to 3. This part here, 12.5 times 4.5, so we're trying to find the initial speed of the second section, and that is just the final speed of the first section. Okay, then plus a half half at squared, a being 12.512, multiplied by 3 squared, we get about 200 meters, okay, for this second section. Third section is the easy one, it's constant speed, so it's just going to be speed times time, 75 meters per second, as we figured out up here, multiplied by 2 seconds, so that's 150. Okay, add up all the total distances and we end up with around about 473 meters. Awesome. The magnitude of the negative acceleration. So moving on to part C. Now, what we do know is that it's total journey. So all 4 types of motion, the fast acceleration, high acceleration, low acceleration, constant speed, and then the negative acceleration, the sums of all the distances add up to 650 as per the question. So the first 3 legs, we can see it adds up to 473. So that just means that the last leg, the distance covered during the last leg is the total distance of 650 minus 473. Okay, so pretty much we know that the final speed is going to be 0. We know that our V is going to be 0. We know what our U is. Okay, or at least we can figure out what our U is. Our U is what we figured out in part A, I should say. Okay, so here we go. There's our final speed. That's our speed at the end of section 2. So V squared is U squared plus 2AS. U again being 75 as per part A. Our acceleration is what we want to figure out. And then the displacement is just the distance difference between the total distance covered and the distance covered during the first 3 legs. All right, so we plug all that in. We get 75 squared over 2 times 177. We end up with 16 ms to the minus 2. Okay, so this is going to be a negative acceleration. Okay, so therefore negative 16 ms to the minus 2. It does say magnitude of negative acceleration. So again, really we only care about the magnitude. Obviously, we don't care about the sign. All right, so D, the total time of this journey. Okay, so basically we go figure out what the time taken for the last part of the journey is, because we know the first 3. Okay, we're told it's 4.5 seconds, and then 3 seconds, and then 2 seconds. Let's figure out what the time is for the 4th section. Okay, so we got V minus U over A, our V being our final speed of 0, our initial speed being 75, and our A being 16. We end up with a time for the last section of about 4.7 seconds, and then legit we just add them all together. Okay, so 4.5 plus 3 plus 2 plus 4.7. Okay, and that gives us about 14.2 seconds. All right, question 1 is done. On to question 2. Question 2, a little bit quicker. So we got a car is moving with an initial speed V and acceleration A. After 3 seconds, the car has gone 30 meters. After 7 seconds, the car has traveled a further 100 meters. Find the acceleration and find the initial speed. All right, so firstly, let's figure out what we've got. We've got our value of t. Okay, we know that when s is 30, we know that t is equal to 3. We don't know our initial speed, however, and we don't know our acceleration. So those are the things that we need to find out, obviously. So let's kind of set up our equation that we're going to use. We're going to use the ut plus half at squared. Now, crap thing about this is we don't know u1, what I've labeled u1 there, which is the initial speed, and a1. We don't know either of those. So let's see if we can do some tricky stuff and try and cancel one of them out. All right, so pretty much let's do what we have for the first part of the question. We got after 3 seconds, displacement is 30. So 3 seconds, when t is equal to 3, we have our displacement of 30. So let's just plug those in. So s is equal to 30, t is equal to 3, t is equal to 3. We end up with an expression of 30 is equal to 3u1 plus 4.5a. All by itself, this is not terribly useful because there are still 2 unknowns. So we need to try and eliminate one of those unknowns. Best way of doing that is using the kind of second set of data. We've got after 7 seconds, the car has traveled a further 100 meters. Okay, so a further 100 meters means, 130 meters in total. So after 3 seconds, it's gone 30. After 7 seconds, it's traveled another 100 meters. So in total, its displacement is 130. So you got 130, our S is 7u1 plus 24.58. All right, so we want to find acceleration first. Pretty much all we need to do is we just label these equations 1 and 2. And then I want to make it such that they both have the same value of A, so that then I can subtract them from each other and I can kind of eliminate. Actually, no, I take that back. I'm totally lying. We want to find A, don't we? I don't want to get rid of it. So I want to manipulate the equation such that my values of u1, so the coefficients of u1 are the same, and then I'm going to subtract them from each other. Then the u1s are going to cancel, and we'll be left with a is equal to something, or blah a is equal to something. All right, so we have here, we're going to multiply equation 1 by 7 on 3. Okay, and that's going to give us 70 is 7u plus 10.5a. Again, I've got in equation 2, 130 is 7u plus 24.5a. And quite easily, because they've both got the same coefficient for u, I can just subtract them from each other. The u's are going to kind of disappear, and I end up with 60 is equal to 14a, therefore a is 4.3 ms to the minus 2. Okay, so when you have 2 unknowns, and both of those unknowns are in 2 separate equations, all you do is you manipulate one of the equations to make the coefficient of the unknown that you're not finding out. You want to make them the same, so that when you subtract them from each other, that particular unknown disappears, which leaves you with the one unknown that you want to find. Okay, so yeah, pretty sweet. And then we just have the initial speed v. So I mean, now that we have our value for a, we can pretty much just go back and plug it into either one of the equations, 1 or 2, and solve for the value of u. Okay, so we do equation 1, multiply by 49 on 4. I think I'm doing it the long way here. So 163.3 is equal to 16.33u plus 24.5a. Okay, and then I've just done 1 minus 2, and I've figured out what my value of u is. Okay, now, I mean, really, what I could have done here, using this value of 4.3, I could have gone back to, this expression up here, and then I could have solved for u1 by doing that. At the end of the day, it really doesn't matter. They're both going to give you the exact same answer, and it's actually a good way of double checking your solution. You can just multiply the values, or multiply the equations by a certain value to eliminate, in this case, our acceleration and solve for u, or you can just use your found value of a into any one of the equations and solve for u, and again, you'll get the same answer. Okay, so 3.6 ms to the minus 1 is our initial speed, and then it's saying the speed of the car after 7 seconds. All right, speed of the car after 7 seconds, I mean, we know what the initial speed is and we know what the acceleration is. Okay, so it's just a matter of finding the correct SUVAT. Okay, so v is equal to u plus at. I want to solve for v, given that my u is 3.6 and that my acceleration is 4.3 and t is 7. Okay, so from this we get a value of v of about 33.7 meters per second. Sweet. All right, that's it for question 2. On to question 3. All right, question 3 is going to take a little while, Padawan, so let's have a quick read through it. 2 cars are traveling side by side at 50. Car 1 accelerates at 1.5 in the same direction as its motion, so in other words, it's speeding up. After 3.5 seconds, car 2 then accelerates at 2.5 until it catches car 1. Both cars then come to a stop. Find the maximum distance between car 1 and car 2. So you've got to ask yourself, like, what is the condition to find maximum distance? Again, there's no such thing as calculus in prelim or HSC physics, and you probably don't even know calculus yet, given that this is like a module 1 question in year 11. The basic way of figuring out maximum distance is, well, car 1 starts to accelerate first, so then sometime later car 2 starts to accelerate. There'll be a point in time where the speed, like where car 2's speed has caught up to car 1's speed. So car 1 is no longer getting away from car 2, nor is car 2 actually approaching car 1. They're both the same speed, so there's no relative motion, let's say. At that point, that's the maximum distance between car 1 and car 2. So we've got to come up with expressions for speed for car 1 and car 2 and basically say that they're going to be the same. Okay, and then we're going to solve for the distance between the 2 cars when their speeds are the same. All right, so let's car 1, we've got 50 plus 1.5 t, so that's just u plus at, u being 50, a being 1.5. Same deal for car 2, so it's our initial speed of 50 plus 2.5 outside of t minus 3.5. Reason why the t value is t minus 3.5 is, again, reading the question, it doesn't accelerate until 3.5 seconds has passed. Okay, so car 1 accelerates straight away. Car 2 accelerates 3.5 seconds later, so therefore its value of t is t minus 3.5. All right, cool. So basically we then just need to, let's simplify that out. So we get 50 plus 2.5 t minus 8.75, or 41.25 plus 2.5 t. And then we're going to say that they must be the same. Okay, so in order for there to be no relative motion, okay, that is the distance between them is maximum, their speeds must be the same, they're not approaching each other, they're not moving away from each other, they're the maximum distance away from each other. Okay, so from here we can solve for our value of t, which ends up being 8.75 seconds. Okay, so 8.75 seconds after the first car starts to accelerate, that's when they're the maximum distance apart. So the second car has been accelerating for 5.25 seconds, whereas car 1's been accelerating for 8.75. All right, awesome. So we can then kind of figure out what is our maximum distance. Well, we're just going to solve for the distance for the 2 cars. Car 1's easy because all it's been doing is accelerating. Okay, so ut plus a half at squared, u being 50, t being 8.75, and our acceleration being 1.5. We can figure out that our displacement for car 1 in 8.75 seconds is 495 meters. Now I'm going to put up the expression for the displacement for car 2, and I'm just going to sit here and stroke my beard for about 5 seconds to see if you can figure out what I've done. I'm sure that didn't look creepy at all, but let's figure out what we've got. We've basically got 2 different parts. We've got this part here, the 50 times 3.5. What's 3.5? It's 3.5 seconds until car 2 starts to accelerate. So this is the distance covered during the 3.5 seconds that he's still going 50 meters per second. All right, then this section over here, this is the remaining 5.25 seconds where it starts to accelerate. So this is ut plus a half at squared. Okay, so this is kind of the displacement or the distance covered during the accelerating part of its motion, and this is the distance covered during the constant speed part of its motion. Right, awesome. So we figure out them two out, 175 plus 297, we get 472 meters. So therefore the maximum displacement between the two cars is just the difference between them. 495 minus 472, which gives us 23. The time elapsed when car 2 catches car 1. So catching car 1 is not the same, not when the two cars have the same speed, rather it's when they have the same displacement. All right, so this one again takes a little while. So displacement for car 1 is ut plus a half at squared. So 50t plus 0.75 t squared. Car 2 is the first part of its motion, so that's just ut, okay, for 3.5 seconds at its constant speed. And then the second part of its motion, so 50 outside of t minus 3.5 plus half times 2.5 times t minus 3.5 all squared. To be honest, it would have been so much easier. Actually, no, I couldn't put the 5.25 in here because I actually don't know the value of t. So the time for it to have the same speed, which we figured out in part A is 8.75 seconds. It's not the same value of t to when they catch up to each other. So we're actually going to have to figure out what the value of t is. All right, so you notice here, blah, blah, blah. There we go. We've got our two expressions, 50t plus 0.75 t squared, then 50t plus 1.25 t squared minus 8.75 t plus 15.3125. Guess what? They must be equal. Okay, so the displacements have to be equal when the two cars catch up to each other, when car 2 catches up to car 1. All right, so that is equal to that. All right, and then basically we get a quadratic expression. We can actually solve for our values. Okay, we get two values here now. The 1.97 seconds, that answer doesn't even make sense because that's 1.97 seconds after the first car has accelerated away. The second car hasn't even started to accelerate yet. Okay, so not a plausible solution there. So therefore we get 15.52 seconds. Now if you plug that 15.52 seconds into either of the displacement equations that we've come up with in part B, both displacement for 1 and 2 is 957 meters. Okay, so the time it takes is about 15.5 seconds and the total distance covered is about 960 meters. All right, so there we go. Question 3 done. On to the final two questions. We're running a little bit behind. Let's see if we can catch up. Question 4, gun is fired vertically upwards. Bullet leaves the gun with a muzzle velocity of 300 meters per second. Find the maximum height. Maximum height, so we're finding S for when the final speed is equal to 0. Okay, maximum height is the turning point. All right, so we have our V of 300, sorry, our V of 0, our U of 300, and we have our acceleration of minus 9.8. We can then solve for S. So S is minus 300 squared on minus 19.6. We get our displacement of about 4,600 meters. So remember, maximum height, the condition for maximum height, we use the same thing in year 12, is when it's turning around, so its vertical velocity is equal to 0. Final vertical velocity equal to 0, that is V is equal to 0 in this question. Time taken for the bullet to return to the ground. Easiest way of doing this is to find the time that it takes to turn around and then multiply it by 2. If it takes 10 seconds to go up, it's going to take 10 seconds to go down because we ignore air resistance. All right, so let's figure that out. T max is V minus U over A. T max is our time to maximum height, which again, same condition as part A, that is V is equal to 0. All right, so we get 30.6 seconds for maximum height. Therefore, the time of flight is just 2 times that. Okay, time taken to go up is equal to time taken to go down. Therefore, we end up with time of flight of about 61 seconds. Speed of the bullet when it reaches a height of 1.5 kilometers. Okay, so basically it's going to reach this height twice, but it should both be at the same speed. It's just that one's going to be going up and the other's going to be going down. All right, so we want to solve for our final speed V with the displacement of 1500. So it's 300 squared plus 2 times minus 9.8 times 1500. We therefore end up with the V is plus or minus 246 meters per second. Okay, so same speed is kind of like a parabola. On the way up, it's going to be going a certain speed. On the way down at the corresponding point, it's going to be going the same speed. So 246, either side of maximum height. The height at which the bullet is traveling 100 meters per second. So it's basically the opposite to part C. Okay, so in this case here, we're solving for S given a certain value of V. All right, so we've got 100 squared is 300 squared minus 19.6 S. Solve for S. 300 squared minus 100 squared over 19.6, and we end up with 4.1 kilometers, basically. All right, cool. On to the last question. We got to go through this so quick. Woohoo! Question 5, Sigma fan. Rock is flung vertically upwards from the edge of a tall building. It takes 25 seconds to reach the ground at the foot of the building. At the same instant, this rock is flung upwards, a marble is dropped from the building, and it reaches the ground 17.5 seconds before the rock. What was the initial velocity of the rock? So it takes the rock 25 seconds, then it takes the marble 17.5 seconds less than that. So therefore it takes the marble 7.5 seconds. That's the first thing to see in this question. All right, so let's just say there that our displacement for the marble, so SM, is ut plus half at squared. Again, here our t is 25 minus 17.5. So it only takes the rock 7.5 seconds to reach the ground. So we get that our displacement of the marble is minus 275.6. Therefore, the height of the building must be positive 275.6 meters. Reason why that's useful is then we can use the same equation for the ball. Okay, and we can say, or sorry, for the rock. So the displacement of the rock is ut plus half at squared. Now we know that overall it falls 275.6 meters. We really don't care that it's gone up first and then come down. What this value here means is compared to, like, how far above or below compared to where it started does it finish? Okay, so this is saying it finishes 275.6 meters below where it started. It doesn't matter if initially it went up or initially it went down. It really doesn't matter whatsoever. Okay, so again, this is displacement, kind of final position compared to initial position. It finishes 275.6 meters below where it started because that is the height of the building. All right, so that is equal to 25u minus 9.8 on 2 times 25 squared. Okay, and pretty much here we just rearrange to solve for u. U comes out to be 111 meters per second. Okay, so again, please do keep in mind for objects being thrown up from a building or something like that and then coming back down and striking the ground, doesn't matter if it's initially thrown up or initially thrown downwards. If you solve for it in one go, which is what we'll do in year 12 as well, we'll also split it up into 2 different parts. Like in year 12, we'll also look at the scenario where we go from here up to max height. Okay, we figure out what the max height is, and then we figure out how long it takes to go down from max height to the ground, using the displacement between max height and the ground. But you can do it in one go, as we've just done there. And given that we knew the value of t, we didn't have to solve for t, then it wasn't going to be a quadratic. Okay, so that's it. Awesome. So we've done our 5 in 20 SUVAT part 2, probably a little bit over 20 minutes again, but hey, it's not really 5 questions we're doing because each question has a billion parts. So it's really 5 billion questions we're going through. Okay, so kudos. Hopefully that helped you guys. If you have any questions, shoot us through an email. Happy to help out. All right, enjoy. See you guys soon.